So how should we be able to determine if the vectors in a space are parallel or not? So now let's say we have a vector, let's say given us, let's say this is a vector A, and we have another vector, let's say given us, let's say this is a vector B. So now if these two vectors are said to be parallel, that means the vectors can be going in opposite direction but they never meet. So which means the vectors that are said to be parallel, they actually never meet. So they can be either in opposite direction or in the same direction, but much as they never meet, it means they are actually parallel vectors. So without having the actually a draw of the vectors, how can we be able to show whether the vectors are parallel or not analytically for the vectors in a space? So the vectors in a space, these are the vectors in three-dimensional coordinate system. That's the vectors in a space. And for instance, let's say we have vector A, and that has been given us, let's say, a 6i, and we have should be minus 4j, and plus a 9k. And let's say we have a vector B that is given us, let's say, 1 over 2i, and the minus should be 2 over 3, should be 2 over 3j, and let's say plus 2 over 3 should be 2 over 4. That should be what? A 3 over 4. Let's say a 3 over 4, let's say k. And let's say we have a vector C, and that has been given as, let's say, 12i, and plus a 9k. Let's say that's the case. And we have, let's say, a vector D, and that has been given as, let's say, I, and minus 4 actually j, there should be plus 2, let's say k. So now how can you show whether the two vectors are parallel or not? So let's start with the vector A as well as the B. How can you show whether these two vectors are parallel or not? Now if the two vectors are said to be parallel, then they must have to obey this condition. Then the vector A has to be the scalar product, let's say, of, now I should have to use this case. Then the vector A has to be equal to the scalar product of the vector B. And also can be a vector B has to be equal to the scalar product of the vector A. That is the essence behind. So in that case, what is actually a vector A? We have it as 6i, so it should be 6i minus 4j, and plus 9k, and which is equal to what is the, now have a scalar product which is n, in times what is the vector B? We have it as 1 over 2, that is I, minus 2 over 3 j, and plus 9k. So which means this n will be distributed. The n has to be distributed and throughout. So in this case we'll have it as a 6i, and then minus a 4j, and plus 9k, which is equal to, now we can have it as n over 2, so it should be n over 2i plus 2n over 3 should be j, and plus 9nk. So should be that. Then we should have to equate these. Actually, we should have to equate the components of these vectors. So have now a 6 is equal, actually that is the I component equal to its corresponding I. This one have to equal that one, and we should have to solve for n in that case. So which means we'll have 6 is equal to, now we'll be having n over 2. So in that case, we'll have it as n is equal to 12, and we should have negative 4 is equal to, let's say, 2n over 3. So in this case, we'll have 2n is equal to negative 12. Hence, n will be given as the negative 6. So that one, and also have it as a 9 is equal to 9n, of which n will be given as the 1. So since the value of n is different, and for the I component, j component, as well as the k component, it means the vectors are no longer parallel. But had it been that the values of n are the same in both components, the vectors could be parallel. That is the essence behind the vectors should be in parallel. And let's think of having, let's say, a vector A now should be, let's say, a vector B as well as the vector C. We should have to show whether those two vectors are parallel or not. Or else we should have to use, let's say, a vector B as well as the vector D. How can you show whether those two vectors are parallel or not? So which means we'll have a vector B is equal to the scalar product of, let's say, a vector D. So which means we'll have it as 1 over I minus 2 over 3 a j, and a plus 3 over 4 should be k, and which is equal to, now a scalar product D times the, actually scalar product n times the vector D, that will be given as, now we'll have it as ni minus 4nj and plus 2nk. So we'll have to equate these vectors in a component. So should be, we should have to equate the x components, y components, as well as the z components. In the sense that we'll have 1 over 2 is equal, now should be n. Now for this case, we'll have it as n is equal to, now should be, now we'll have it as, upon having the cross multiplication, we'll have n is equal, what is that one? Because we have n is equal to 1 over 2. Cross multiplication, we'll have it as 2n is equal to 1. So we'll have it as n is equal, so should be 1 over 2. So that is, and how about this one? In that one, we'll have it as, should be negative 2 over 3, and is equal to negative 4. Now the cross multiplication will have, so should be negative 4n, by the way. Now we'll have it as negative 12n is equal to negative 2, of which obviously the value of n will be different for all vectors, actually will be different for all components. Hence the vectors are no longer parallel. So take note of that. Now it should be this way. I should have to remove this. So try to choose the pair in which the vectors, now you should have to try to actually have to approve, let's say, the vector A as well as the D, or A as well as the C. Try to have those out at your own time to show whether the vectors are parallel or not. Now what if we have this pair? You should have to know. Let's say we have a vector M, let's say being given as, in the component form we'll have it as 3, 2, negative 5. Let's say we have a vector n which is given as, let's say, negative 6, and negative 4, let's say we have it as 10 here. And also we have, let's say, vector b, and which is given as, let's say, 2, let's say 4 over 3, and that should be negative 10 over 3. Let's say that's the case. And we have another vector which is given us, let's say 6, 4, 10. Let's say this is, that should be a vector q. Let's say this is a vector q. So should be that. So how can you show whether the two vectors are parallel or not? So let's think of, let's say, having to try to look over that one for the first two vectors. So in this case we'll have, so of course let me just have to move this one, and of course at one time we also have to try to show whether, let's say, a vector p has the QRPAR, or whichever the combination you should have to choose. But for the meantime, let me just have to omit this one. Now a vector m has to be equal to the scalar product, let's say given as, let's say, d of the vector n. So which means we'll have it as 3, 2, -5, which is equal to d. So now a d times the vector n, so which means we'll have it as a 6d, comma, let's say -4d, and we'll have 10d. That's what we'll have it. So which means we'll have 3 is equal to -3d. So it should be -6d. So in this case we'll have d being given as 3 over, now should be 3 over -6, which is the same as 1 over -2. And also have 2 is equal to -4d. So in this case d will be given as 1 over -2. And we'll have -5 is equal to, let's say, 10d, of which 10 will be actually, d will be given as -1 over 2. So now since the value of these are the same, it means the vectors n as well as the vector m as well as the vector n, they are parallel. So take note of that. So the vectors are actually parallel. Now from the fact that the values of these are all negatives, it means the vectors are going towards the same direction. Because if it happens that the constant, let's say a constant, let's say d, is given as, let's say, -2, let's say +2, let's say -2, it means these two vectors, that should be, it means these two vectors are going towards the negative. Actually they are going in opposite direction. But if we have, let's say, a constant given as a -d, let's say -2, -2, -2, -2, it means they're going towards the same direction. So our focus is on the magnitude or the value of the d. So if the values of the d are the same, let's say 2, 2, 2, despite that the other one is negative or positive, it means the vectors are parallel but they're going in opposite direction. But if the signs are the same, it means they're going in the same direction. So take note of that. So try to go through the other pairs as well. You have to see if the vectors are parallel or not. So thank you.